Hello students, welcome back to lecture series of mathematical methods in physics of M.Sc. part 1. In the last class we discussed about the Laguerre differential equation and its solutions in the term of the power series. So here in this lecture we are going to discuss recurrence relations. Okay, so first one, that is x minus 2n minus 1 into ln x plus ln plus 1 plus n square ln minus 1 is equal to 0. This is the first recurrence relations. And second one, that is the l prime n minus n into l prime n minus 1 plus n into l n minus 1. Okay, and this ln is the Laguerre polynomials, okay, which is function of the x. So here we are going to prove this first one and then the next one. So this first recurrence relation I am going to use here generating functions. So generating functions of this Laguerre differential equation or Laguerre polynomial, that is e raised to minus xt divided by 1 minus t is equal to 1 minus t into summations n is equal to 0 to infinity ln, which is function of x into t power n divided by n factorials. Okay, so this is the generating functions of the Laguerre polynomials. Okay, and this is equate is equal to this polynomials, this ln x, that is the coefficients of the t power n by the n factorials. Okay, so this equation first. Okay, so if I this differentiate with respect to the t, okay, then we get minus x divided by 1 minus t bracket square e raised to minus xt divided by 1 minus t is equal to 1 minus t summations over n is equal to 0 to infinity ln is function of x into n into t power n minus 1 divided by n factorials, and here is a minus, so t into t power n. So here I am going to use the u formula. Okay, so if I differentiate this thing, so it is minus summations n is equal to 0 to infinity ln, which is function of x into t power n divided by n factorials. Okay, so after the differentiate with respect to the t, we have the expressions this one. Okay, now this expression e raised to minus xt by 1 minus t, we equate with these things. Okay, so x by 1 minus t square and into 1 bracket 1 minus t into summations our n is equal to 0 to infinity ln x by n factorial into t power n. So this 1 minus t and the square will be cancelled out. Okay, so here minus x divided by 1 minus t bracket square into 1 minus t summations over n is equal to 0 to infinity ln is function of x divided by n factorial into t power n is equal to 1 minus t into summations n is equal to 0 to infinity ln into n t power n minus 1 divided by n factorials and minus summation over n is equal to 0 to infinity ln, which is function of x into t power n divided by n factorial. Okay, so here this will be the cancel out, and minus x divided by 1 minus t into summations n is equal to 0 to infinity ln to x divided by n factorials into t power n, and or so I am directly right here, that is if I multiply here to the both side, left hand side and the right hand side, with the 1 minus t. So it is minus x summations n is equal to 0 to infinity ln is function of x divided by n factorials into t power n is equal to 1 minus t bracket square summations over n is equal to 0 to infinity ln x into n into t power n minus 1 divided by n factorials minus 1 minus t summation over n is equal to 0 to infinity ln x into t power n by n factorials. Okay, after the multiply both side by the 1 minus t. So these equations, if I simplify these expressions in this term, so it is 1 minus x into summations n is equal to 0 to infinity ln x into t power n by n factorials plus 1 minus t bracket square summations n is equal to 0 to infinity ln x into n factorials into n t power n minus 1. Okay, and the minus 1 minus t summations n is equal to 0 to infinity So from these expressions, now next task is just we equate the coefficients of the t power n. Okay, so we need the here t power n by the n factorials. So for that I am going to just replace here n with the n plus 1 and here. So before that just I open this bracket. Okay, so if I open this bracket, so it is x into summations n is equal to 0 to infinity ln into x by n factorial into t power n plus, so 1 minus 2t plus t square. Okay, so 1 minus 2t plus t square into summations n is equal to 0 to infinity ln x by n factorials into n into t power n minus 1 minus 1 minus t. Okay, summations n is equal to 0 to infinity ln x divided by n factorial into t power n. Okay, so now multiply with these things to the bracket. So 1 minus 2t, so this t power 1 and here is a t power n minus 1, so plus 1 and minus 1 will be cancelled out, and here is a t power 2, so n minus 2 plus 2. Okay, so here t power n plus 1. Okay, so here we get a total 3 terms and here is a 2 terms. Okay, if I multiply to the brackets, x into summation ln is function of x divided by n factorial into t power n plus summations ln into x divided by n factorial into t power here n into t power n minus 1 minus 2t. Okay, so it is summations ln is function of x into n into t power n minus 1 divided by n factorials and plus t square summations ln is function of x into n into divided by n factorials. Okay, and if I multiply with this bracket, so here minus summations ln x into t power n divided by n factorials, and there is a plus t summations n into ln to t power n. Okay, so here is a t power n, here t power n minus 1, here is also t power n minus 1. So in these three terms I am going to just put n is equal to n plus 1 in the first second summations, and in the third summations I am going to put, okay, here is a t power 1, so this t power 1 and the t power n minus 1 will be, this minus and the plus 1 will be cancelled out. Okay, so here you have the t power n, and here t power 2 into n into t power n minus 1, so plus 1 and minus 1, so here is a plus 1. Okay, so now we have the t power n. Okay, so if I write again x summation ln x into t power n divided by n factorials plus summations ln x, okay, summations n into ln x divided by n factorial into t power n minus 1. So here I am going to put n is equal to n plus 1. Okay, so it is summations ln plus 1 into t power n, and here it is n factorials. Okay, this n by n factorials we write the 1 by n minus 1 factorials, and the n, if I replace with the n is equal to n plus 1, so minus 1 and plus 1 will be cancelled out. Okay, so minus 2 summations n into ln t power n divided by n factorials, and plus ln minus 1. Okay, here is summation l n minus 1. Okay, so here I am write like this. In these terms summation we need the t power n only, so for that I need to put, so these expressions we can write like this also, n minus 1 factorials. Okay, so if I put the n is equal to n minus 1, so it is summations n square ln x and t power n divided by n factorials. Okay, and here minus summations ln x divided by n factorials into t power n plus t power 1 and here t power n, so n plus 1. Okay, so summations ln is function of x t power n plus 1 divided by n factorials. Okay, so here I am going to just put the n is equal to n minus 1. Okay, so these expressions become n into ln minus 1, which is function of x t power n divided by n factorials. Okay, so now I am going to just equate the coefficient of the t power n by the n factorials. Okay, so if I equate is equal to 0, then we get this relations. Okay, so x minus 2n minus 1 into ln x plus ln plus 1, which is function of x, and plus n square ln minus 1 is function of x is equal to 0. Okay, so this is the recursion relations of these Lagrange functions. Okay, so okay, we will stop here. We'll discuss in the next lecture.